August 23, 2010. The Millard Refrigerated Services Facility in Theodore, Alabama. More than 32,000 pounds of anhydrous ammonia was released to the atmosphere after a pipe within the plant's refrigeration system catastrophically failed. The Chemical Safety Board investigated and found that the ruptured pipe was caused by hydraulic shock, which is defined as a sudden localized pressure surge in piping or equipment, resulting from a rapid change in the velocity of a flowing liquid. Following its investigation, the CSB released a safety bulletin describing key lessons for preventing hydraulic shock in industrial refrigeration systems, which, if followed, can prevent dangerous accidents like the one at Millard. In 2010, Millard Refrigerated Services operated a frozen poultry export facility near Mobile, Alabama. The facility maintained a 143,000-pound capacity ammonia refrigeration system with 8 separate freezers. Within the system, low-temperature liquid ammonia is pumped through evaporator coils. As the liquid ammonia evaporates, heat is absorbed, cooling the freezers. During the process, the outside of the evaporator coils builds up frost due to contact with moisture in the surrounding air. Unless this frost is removed, it will reduce the ability of the coils to effectively cool the freezers. To avoid this, defrost cycles are initiated periodically. During a defrost cycle, the low-temperature liquid ammonia is removed from the evaporator coils completely and replaced by hot, high-temperature ammonia gas, which fills the coils and melts the frost on the outside surface. Once the frost is melted, the hot condensed liquid and remaining gas are removed from the evaporator coils before low-temperature liquid ammonia is pumped back in to resume normal operations. On August 22, 2010, the Millard facility experienced a loss of power that lasted more than 7 hours. During that time, the refrigeration system was shut down. The next day, the system regained power and was up and running, though operators reported certain problems. While doing some troubleshooting, an operator cleared alarms in the control system, which reset the refrigeration cycle on a group of freezer evaporators that were in the process of defrosting. The control system reset triggered a valve to open, and low-temperature liquid ammonia was fed back into the evaporator coils before removing the hot ammonia gas. This caused the hot, high-pressure ammonia gas to rapidly condense into a liquid. A vacuum was created where the gas had condensed. The void sent a wave of liquid ammonia through the piping, causing a sudden pressure surge known as hydraulic shock. The pressure surge ruptured the evaporator piping manifold inside one of the freezers and its associated 12-inch piping on the roof of the facility. 32,100 pounds of ammonia were released into the surrounding environment. The large cloud traveled a quarter mile from the facility south toward an area where 800 contractors were working outside on a cleanup site for the Deepwater Horizon oil spill. 153 people were exposed to toxic anhydrous ammonia. 32 of the off-site workers required hospitalization. 4 of them were admitted to an intensive care unit. During its investigation, the CSB learned that the operator who was attempting to troubleshoot equipment issues after the power outage manually cleared alarms that reset the evaporator controls. Due to the reset, the control system did not recognize that the evaporator was already in the process of defrosting and allowed the refrigeration cycle to start without removing the hot ammonia gas from the evaporator coils. The CSB notes that one lesson learned is to avoid the manual interruption of evaporators during defrosting and to ensure that control systems are equipped with security devices so that only trained and authorized personnel may manually override programmed operations. And after an unintended interruption of service, hydraulic shock can be avoided by programming the control system to automatically remove contents from the evaporator coils prior to restarting refrigeration. The CSB also found that the evaporators at the Millard facility were designed so that one set of valves controlled 4 separate evaporator coils. As a result, the contents of all 4 coils connected to that valve group were involved in the hydraulic shock event, leading to a larger, more hazardous pressure surge. The CSB notes that when designing ammonia refrigeration systems, each evaporator coil should be controlled by a separate set of valves. And the CSB found that immediately after discovering the ammonia release, a decision was made to isolate the source of the leak while the refrigeration system was still operating, instead of initiating an emergency shutdown. A final lesson learned from the CSB's investigation is that an emergency shutdown should be activated in the event of an ammonia release if a leak cannot be promptly isolated and controlled. Doing so can greatly reduce the amount of ammonia released during an accident. The CSB believes that if ammonia refrigeration facilities follow the lessons learned from its investigation into the accident at Millard Refrigerated Services, dangerous hydraulic shock events can be avoided. For more information about the CSB's Millard Refrigerated Services investigation, please visit csb.gov.